In this video, we're going to be looking at envelope generators. These have been used on most synthesizers throughout history. We can see some here that are available on some common synths. There are a few different types, with various combinations of multiple stages. The modules we have in MooMu are the attack decay module, the attack release module, the attack decay sustain and release module, and their bigger brother, the envelope generator. The first three modules are slim versions of the envelope module, with a simpler UI and taking much less UI space. For the remainder of this tutorial, we shall concentrate on the envelope module. Right, let's take a look at the various modes so we can get a better understanding. On our scope, we can see the output of our envelope generator. If we also send a copy of the trigger to the scope, we can see on the scope, this is the duration of the trigger. So the concept of an envelope generator is to receive a gate signal, such as a note being played, and then produce a varying control voltage we can use to control the signal, often volume. We'll go over the attack, decay, sustain, and release mode first, as the controls from this transfer to the other modes. As we can see on the left-hand edge of the scope, this is when the clock signal is turned on. It may represent a key pressed. This is the duration of our notes, and our note turns off here. After the gate is turned off, you can see this little tail. We can control the duration with the release control. This flat section in the middle here is the sustaining level of the note. This is adjusted with the sustain control. We can see the attack and decay portions at the start. We can use the mode switch on the top row. This will allow us to alternate between the varying modes.
The top position is the ADSR mode we've just looked to find the rigid plates in.
In the middle position, this is just the attack and decay, commonly called AD. We'll note that the length of the gate does not affect the length of the note. If we adjust the sustain control or the release control, they have no effect. The third mode is attack and release, often called AR. Now, the attack control responds the same way as all the other modes. We hold at the full voltage level here until the end of the gate signals. As we can see, we'll then get the release phase, during which we can adjust the release duration. Now we have an understanding of the various modes. This will get us a long way. Let us look at the function of the remaining switches on the top row. We shall look at some of the other controls. We have the re-trigger control next. This will allow us to feed a second input into the trigger input. When turned on, we'll see if we have a mixture with a pair of shapes. When we're outside of the clock, we get a different release. We get the decay curve and the release. Inside the keyed area, we don't get the release phase. Here, we have a 16th note clock running. We can see our clock signal on the scope in blue. The green is the envelope generated. And as we can see, the envelope signal is fully decayed before the next signal starts. If we were to increase the release times, we will see that the signal never reaches zero. If we click on the reset switch, this will reset the envelope generators to 0 on the start of the gate. The final switch is the cycle. Once an envelope is finished, it will send a trigger from the EOC end of cycle output and restart the envelope similar to an LFO. As we can see, we have a very short duration. Each cycle is re-triggered when the envelope reaches 0. If we increase the time of our attack, we will notice the cycles getting longer. And the same will happen with the release and decay levels. we now have a longer duration. The cycle function can be used in all modes, ADSR, AD, or AR mode. To get the best results, experiment with the 3 modes and find what sounds good to you. Now that we understand the concept of stage timing controls, let's look at each stage. Okay, we will look at each row here. We have the knob to control the timing or the level in sustain instance. Those timing values can be affected by CV. Simply plug a CV signal into one of these inputs on the left-hand side. As normal, the attenuator controls the amount of effect our CV signal has. We have some gate outputs on the right-hand side, one in each stage. Here you can see the envelope on the scope. We can adjust the various stage timings. We can view these stage gates. There's our attack phase. There's the decay. We can see we only have a very short amount of sustain left there. Let's turn the decay down to make this more apparent. So now we can see the sustain stage. And the release, if we move our gate output, is highlighted. We have covered all the controls. Now it's down to your imagination. Right. We're now going to show what we can use an envelope generator for. The VCA voltage controlled amplifier. It's so common with the use of an envelope generator. There's one included. We can take a signal from a noise generator, feed it into the VCA on the envelope generator. Then the VCA on the envelope generator goes to the audio module. Now we have used the envelope generator to create a collection of percussion sounds. We shall be creating more sounds soon. Let's take a look at the bottom row of the envelope generator. We will see our gate input that we've already covered, the trigger input, which we covered when looking at the reset switch. We have an EOC end of cycle output. So every time the envelope generator reaches 0 volts, we'll get a trigger from the end of cycle output. And the envelope output that we've been looking at in general. Phew, that's the theory of the envelope generator covered. Now we can try some examples with our newly found knowledge. Right, here are some synth examples to end this tutorial. We use this as volume control in a very simple synth. Here we have a clock module on the left, followed by 2 sequences, one providing CV voltage for pitch and one providing our triggers. A quantizer for our pitch, where we'll pick some notes that we'll use. This is our oscillator. Let's turn that into a more interesting sound. And our envelope generator, the output of the wavetable goes to the VCA on the envelope generator, and the triggers go into the gate of the envelope generator. So if we take the audio from the VCA output to the audio out, and now we can adjust our times. From a very shortest thing we can do here, the tiniest percussion. Increase the sustain. Increase the decay. And we have a little riff going on. And again, we can play with those parameters. That's it, folks. We now have the knowledge to use the envelope generators in MooMu. All that's needed now is imagination and inspiration. If you like this content, please hit the like and subscribe button.